Leave an ice cube in the bright sun, and it melts in minutes. Leave it in the shade, and it survives much longer. It is a simple, everyday observation. But the moment you look at that puddle of water and ask why it happened, you are doing science. Often, we are taught that science is a heavy textbook filled with static lists of facts and dates to memorize. Science is a dynamic process for mapping the complex mechanics of the universe. In the 17th century, a man watched an apple fall from a tree. He didn't just record the event, he actively questioned why the object fell toward the ground instead of floating up into the sky. Isaac Newton didn't invent gravity, but his drive to question a mundane, everyday occurrence led to the mathematical equations that describe how objects attract each other across the cosmos. Human curiosity drives discovery. Asking why is the mandatory first step of all scientific progress, but asking questions only gets us so far. To actually find reliable answers, we need a system. We call this the scientific method. This diagram illustrates the method. It starts with an observation, noticing a wilting houseplant. That leads to a hypothesis, guessing the plant needs more sunlight. Next, during experiment and data analysis, we test the hypothesis by moving the plant to a window and tracking its health. Often, the plant keeps wilting. The initial guess turns out to be completely incorrect. A failed test provides valuable new data. It forces researchers to revise thinking, eliminate a variable, and test a new hypothesis, like checking the soil moisture instead of the light. By constantly testing and adjusting, the scientific method acts as a self-correcting tool, turning simple guesses into the reliable evidence we use to build our world. This same method of testing and observation provides the physical blueprints for modern technology. By observing how energy moves from a hotter object to a colder one, a physical concept known as heat transfer, engineers developed the controlled environments of the modern stovetops and ovens used in our kitchens. By analyzing the microscopic structure of plant fibers, early innovators developed the material science required to spin raw cotton into the mass-produced textiles we wear every day. And by rigorously testing how air flows over curved surfaces to create lift, researchers translated the abstract principles of fluid dynamics into commercial aeronautics. Flight, synthetic fabrics, and electric heat did not appear by magic. They are the direct, cumulative results of generations of people applying the scientific method to everyday problems. Science operates far beyond the walls of an academic laboratory. It is the physical foundation woven into the fabric of our daily lives. Scientific inquiry also catalogs the wild, diverse environments of our home planet. When we examine a single cross-section of a forest or an ocean reef, we find biodiversity, a term describing the massive variety of life coexisting within habitat. This graphic shows a food chain's precise interdependence. It illustrates linear energy transfer. A plant absorbs sunlight, an insect consumes the plant, and a bird eats the insect. Zooming out, the diagram overlays this chain with massive physical processes: evaporation, condensation, and precipitation. The water from a puddle that dries up today becomes the clouds of tomorrow, eventually raining down to sustain ecosystems hundreds of miles away. Earth operates as a massive, perfectly balanced, interconnected machine. Science provides the tools to trace how every individual piece relies on the others. And when we look past our own atmosphere, we can place that interconnected Earth within the vast mechanics of the solar system. At this scale, scientific discovery is an iterative process. Each new finding can force us to rearrange our existing understanding of the cosmos. For decades, our maps of the solar system included 9 major planets. As telescope technology improved, we gathered new data on Pluto's size and neighboring objects, forcing astronomers to officially reclassify it as a dwarf planet. That same process of continuous observation happens whether you're mapping the edge of the galaxy or just looking at the plants in your own backyard. Scientific knowledge is never absolute. The facts we confidently rely on today might be refined or completely rewritten tomorrow as we gather better evidence. You don't need a lab coat or a PhD to participate in this process. You just need to look at the world, stay curious, and never stop asking why.